we have to show that the given lines are coplanar, and then we have to find the equation of the plane containing these two lines. Now, the given lines are x minus minus 1 upon minus 3, y minus 3 upon 2, z minus minus 2 upon 1, and x minus 0 upon 1 is equal to y minus 7 upon minus 3 is equal to z minus minus 7 upon 2. Now, x1 is equal to minus 1, y1 is equal to 3, z1 is equal to minus 2, and a1 is equal to minus 3, b1 is equal to 2, c1 is equal to 1. And now x2 is equal to 0, y2 is equal to 7, and z2 is equal to minus 7, and a2 is equal to 1, b2 is equal to negative of 3, and c2 is equal to positive of 2. Now, the lines are coplanar if x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, and a2 b2 c2 is equal to 0. Now this implies, now x2 minus x1 0 minus 1, y2 minus y1, y2 7 minus 3, and z2 minus z1 minus 7 negative of minus 2 upon minus 3 to 1 and 1 minus 3 2. Now this is equal to 1 4 minus 5 minus 3 2 1 1 minus 3 and 2. Now expanding along R1, now we are getting 1 with 4 plus 3, minus 4 with minus 6 minus 1, minus 5 with 9 minus 2, and this is equal to 7 plus 28 and minus 35, which is equal to 0. Now hence the given lines are coplanar. One thing. Now we have to also find the plane containing these two lines. Now the plane containing two lines is given by x minus x1, y minus y1, z minus z1, a1 b1 c1, and a2 b2 c2 this is equal to 0. Okay, so we are having now x minus x1 minus 1, y minus y1 3, and z minus z1 is minus 2 with a1 b1 c1 minus 3 2 1 and 1 minus 3 2. Now expanding this one, sorry. Okay, now let's see what we are getting. Now 7x minus 7 plus 6y okay, so I am sorry, it is negative of 7, so this is plus 7y and minus 21 plus 7z and plus 14 is equal to 0. So we are having 7x plus 7y plus 7z is equal to 0, or x plus y plus z is equal to 0. Required equation is x plus y plus z is equal to 0. Answer.